Okay.
Moneymaker right here.
We'll have that recording.
All right, all right. So it's week 12, which means this is technically lecture 23. We covered a fair amount of thank you. We did a fair amount of solar theory, did a fair amount of wind theory. I think I've got you in a dangerous enough position on that. We covered some, very important concepts. One being that power through any system is always the product of some through variable and some across variable. I hope I've kind of hit you over the head with that enough times. It's something that I remember hearing in college, kind of second year engineering courses, and it's something that stuck with me a bunch. We also struggled through the units, dimensional analysis a little bit. You saw me kind of going down the rabbit hole, and I managed to pull myself back out. It happens. So any system, whether it's mechanical, electrical, and it doesn't matter what kind of mechanical. It could be purely kinetic, it could be kinetic and potential. It could be thermal. That's what we did last time. We did the thermal analysis, looking at the flow rate as your through variable, and the temperature difference was the across variable in that case. We just kind of had to dig it out, and then also looking at sort of sizing the technology appropriately so it sort of matches with whatever nature is going to give you, right? You don't make your technology so dang big that nature's never going to put in as much as it can take, and vice versa. Don't undersize the system either. So I think we went over that. So with that, I thought what we'd do today is just get into the projects a little bit. And I did leave a spot for uploads. I hear an oh no coming from one side of the room. Do you have something, you just didn't send it up there, or what's
I was going to kind of go with Dustin on his thing. And
That's fine.
Just forgot to write a paper.
That's fine, that's fine. Like I said, it's just the one page is all I'm looking for. Another thing I want to mention is funding your project. So here's the policy on that. And I'll just take Ryan as an example. If you want to make a project, build a system that's going to go on like your buddy's garage, for example, a couple different ways to handle that financially. We do have funds to buy materials that are used in class to build something. Now, if your buddy then wants it on his house or office building instead of our campus, then I think the most equitable way to take care of it is just to have him pay for the materials, right? And so what that individual then gets out of it is sort of the free labor of us building, designing and building the system here, and then they get sort of a discounted system. It works as well as it works. He saves some money. Missoula College has gotten some good community PR, and the student, have gotten the experience of doing the hands-on. So it should be a kind of a win-win-win all around. Another one I think Ryan's doing is just straight up buying the materials himself, and then his buddy's going to pay for that. And really the service that the college is providing is the management system, the information management system. And I just shared Tim's project with you today, Ryan, and it's something that, sure, you might be able to get the thing online with YouTube or whatever, but can you call up the YouTube guy? Maybe not, but that's what I'm paid to do. I'm paid to provide the interpretation between whatever junk you might be seeing out there, whether it's YouTube or our very own textbooks. That's the service I'm providing. It's the same one that we're paying Tim to be the teaching assistant for this class, so he can sort of share his experience and streamline it, so the next time it's easier. Until you start making it all fancy, and then it gets harder, right? So.
Yeah. Well, it just makes sense for the previous one to make it, I'm still not gonna get the name, we're just gonna call it the open source logic board.
Oh.
The Adroni, I'm gonna say.
Oh, you're saying Arduino, yeah.
Anywho, because it makes sense to have it be able to have two set programs, one for winter,
Mm-hmm.
and then make one for summer where it does the exact opposite.
Yeah.
It takes the heat out.
Cools at night, yeah. Mm-hmm.
But it just becomes a very complex.
Yeah, it's not a simple task, and that's something that, designing that circuitry is a little beyond the scope of NRGY 242. That said, it fits right in with a Steve Shen or a Steve Stiff PLC's course. I mean, they'll just nail that all day long, so.
Yeah, so that's, building the said panel is going to take about a weekend.
Yeah.
A couple of hours.
Yeah.
But that is going to be and then I would imagine that would be hooked up to a relay, which then you would power your fan.
Yeah. Okay, so I will, let's just see what's been turned in so far, and I thought we'd just go over that right now in class. Internships in thermal. And then, Corey, since you're still working on your submission, we can just talk about yours in general today. Thought that was week 12. Oh, was it here we go, week 9. Submitted 2. All right, let's take a look then. So Joe, do you mind if we just look at yours then?
Sure.
Class? Okay.
It's not quite complete.
Yeah, it's all right. Just having a start is.
Yeah, I just haven't priced all the materials.
Okay. Okay. All right, so solar thermal heater. Remind me, are we doing, I'll just kind of grade this on the fly. Was something smelly back there in the trash? Oh, curious. I'm always obsessing about the garbage in my house too. I don't know what it is, man.
One person can only do so much world saving, right?
And I'm yet to reach my limit. I'm gonna make a new folder. So this is proposals. Open. Another thing, guys, just I'm gonna say this is when you name these, it'll help me if you just use your last name as the first, because that's how I organize them in my folder, but you do me a favor and just do that. Okay, so now, air or liquid?
Yeah.
Okay. I guess I'm tempted to just put the word air right here. Thermal air. It's also going to be an air exchanger, or are you doing? Do you have a two separate air handling systems? Do you have like a closed loop air, or is it open?
Yeah, it'd be pulling air from the room, going through the system and back into the room.
Okay. Okay. Similar to what we had with
Right.
Okay, got it, okay. So with thermal air, I'll just leave it at that. All right, timeline, week of November 10th through 12th, material price and purchase, that's good, we're right in the middle of that. 17 to 24. Now, do you, is this going to be something that is going to stay on campus, or something you're going to take elsewhere?
Yeah, I thought it was gonna replace the
On campus?
one that was
Okay, great, yeah, so we can just pay for that. We'll just pay for that with National Science Foundation, Department of Labor funds.
And how does that work? We just all go shopping?
Well, it's a little complicated in that my credit card does not work for supplies. I can only use it for travel. But if you've got a list of things, like say you can get from Ace or Home Depot, we can just send that to Kelly Wasson and she can just buy it with her credit card. And we've had Home Depot deliveries happen already, so I know that'll work.
Cool.
And so that's option two. A third option would be for, and I've been forced to do this recently too, where I've just gone and used my own personal funds, bought something, and then I get reimbursed a couple weeks later.
That's probably the easiest.
It is the easiest, it's not ideal, but it probably is the easiest. If you want to do it that way, if you want to do it that way, that's fine.
Okay.
Yeah, we can do it that way.
So it's not like it's thousands of dollars.
Sure, and the checks come back. If it's less than $50, you can just do it petty cash. If it's more than 50, it takes a week or two for the check to come. It just comes back to the mail, so.
Just gotta keep receipts and.
Yeah, absolutely. Yeah, just be sure you keep the receipts, and, yeah, there's a little form, and it just goes right through.
I mean, so kind of like we're building like the same.
Very similar, yeah.
The
Mm-hmm.
same project.
Mm-hmm.
I'm just wondering, like, I know you have the example, but Tim, do you have the actual design of that panel?
Ryan and I were looking through your report last year, and you had some good, kind of PowerPoint-y deals, but do you have a set of hand drawings with dimensions at all on it, or just kind of like,
No, it's all on here.
hey, the thing's 8 feet by 4 feet, start there and just start lopping her down as a frame?
Start in the middle and work your way.
Yeah, okay.
14 columns, 17,
Yeah.
17 columns of 14 pans,
Yeah.
whatever that dimension is.
Mm-hmm.
That's where the headers go. The rest of your space is intake and exhaust.
Yeah, okay.
Did you say you still have a shitload of cans?
Yeah.
Yeah, and I got a bunch sitting under my desk. I was just over at facilities today. There's a mountain of them over there. I've got 6 bins. I still got to eat. I went a little rogue over at facilities and still.
Borrowed with the intention of.
No, I mean, because every day I walk through the Commons and Lisa Swallow is like, Brad, where's the recycling cans? So today I was over there chucking some recycle at the center, and I realized, oh, they're sitting under a pile of snow and leaves at facilities. Maybe I'll just rescue them. So I put one paper bin on my bike and then some other. Anyway, I'll put the green bins out in the Commons, and we'll have even more aluminum coming right in. So I'll do that.
$3.99.
What?
$3.99.
Or you could just get super amped on Mountain Dew.
That's better
The whole
than
thing in 2 days.
cold smoke.
Get a bunch of handy cases of PBR.
Well, my thing is, I've never seen the original, so I don't actually know how to build one.
Yeah.
I can make a frame, and I could, yeah. My thing is
Maybe.
I don't exactly know how to design the thing.
Yeah, guys, where are we with the whole Nikki Robinson deal? Because I was really thinking I would kill 2 birds with 1 stone. My wife's not quite ready to bite the bullet and mount it on the side of my house. It's sitting there next to my house, ready to be installed. But can it go on Nikki's house or not?
No.
Okay.
I'm not gonna do the work.
Now, just tell me why though. I mean, is it just
I just don't think
Just
it's
doesn't
cost
get enough
effective.
not enough sun?
Because, did you see,
You didn't go on-
I sent you the.
Actually, let's go over those real quick, Brad,
You,
'cause I said
you
that
didn't.
we would.
You didn't go on the roof though.
You can't go on the roof, you can't blow the heat down. It'll take more energy to blow the heat into the house than it would than what would be saved by the heating.
I don't know. Some reason
We need to.
I want to know. I mean, in theory, I think it might be true, but I kind of want to.
Break out that solar pathfinder.
I want to know
We've
that.
got the-
Yeah, I already sent it to you.
Oh, you did?
It's, under,
Is it in my email?
yeah, on our
The month
email
of
strand.
December, she gets absolutely zero sunshine.
In December?
Yeah.
Even on the roof? Because it sounded like you guys didn't go on the roof.
We went pretty close.
Didn't go on the roof.
Yeah, well,
Okay.
I'm not gonna get on the roof in solar panel. I'm just telling you, and I personally don't wanna drill any holes in somebody's roof. I've never done any construction roofs, so.
Yeah, I would have a concern about water and more of a concern that she's gonna have holes in her roof and not see any gain out of it.
Yeah.
That's like probably the most horrible solar pathfinder chart I've ever seen.
Okay.
As far as, I mean, literally, she couldn't pick she'd be okay with solar PV, but she couldn't pick a shittier place for solar.
Yeah. I didn't realize how backed up against Mount Sentinel she is right there.
Yeah,
But
and it's literally the worst house in Missoula County.
I
pretty
would
much.
be willing to entertain solar hot water maybe, but not solar.
where are you getting the, I mean, why would you go water and not air?
Because I could put that on the roof and pump it.
Oh. Gotcha.
And there's more mass involved, so it wouldn't take as long to heat up, right?
Well, it'd take longer to heat up,
Well,
but it would hold
yeah.
better. I think, and the advantage of that is you're running a quarter horsepower pump instead of 120 volt. You know, you'd have to have a pretty monster fan to get any heat out of that solar thermal panel to move hot air.
I think I can open this thing with Word, can't I?
Should be. Didn't I send it in more than one version?
No.
You send us a PDF or what?
It's a WPS. Was that Word Perfect?
Word should open it.
It'll open it. Let me just force it to here.
Word opens it.
Just
Download the new converter. Sure. Sorry about the delay. Download.
I'm sorry, I should have sent it.
No, it's all right. Select the checkbox. What the heck is that? No thanks and continue. I don't need, yeah, just get it over with. Save file, desktop, save. It's all right.
You're just texting me, my bad.
Not a problem.
But anyways, I highlighted the wax with a highlighter so that you see. Just came in.
Are we done? File, open. Proposals, Bruce, Robinson, office, courses, for God's sakes. Okay. Yes, I have a lot of files on my computer. Come on, come on, you can do it.
Trying really hard.
Yeah, my machine has not been behaving all that great. I'm close to some other stuff. Joe, we'll get back to yours in a second. Kill some of this junk. Yeah, it's weird. See this blank? Yeah, I'm scrolling through here, and this window is just blank. I mean, Word thinks that thing is being shown, but it's just not.
Does anybody have their hard copy chart with them?
No.
Yeah, they're at my house.
I'll get it here. Close this camera.
The other thing we could do is, because we still have I still have the charts from the hydrogen plant.
Yeah,
And we could use that as a comparison and say, look, this, and we did the math on that, and that was like 4.5 kilowatt hours per day, I think. And compare that one, we could do an overlay of that one and her Solar Pathfinder
mm-hmm,
to show that she would get less than 1 kilowatt hour per day.
yeah. There we go.
So at 7 cents a day, you're kind of pulling your roof? I wouldn't.
Yeah.
Man, that's a good trace job, who did that?
Beauty.
You like my name for your project?
Not so easy street. Nice.
Just keep scrolling down.
Yeah. So I mean, what we'd like to see is a big fat line. The whole thing is full. What's going on here? Why is it?
That's from the roof. That's the roof.
Oh, okay. All right.
If you scroll down, you'll see.
That's the roof line looking west.
The one that's, I labeled each, there's two of these.
Okay.
So one's like on the side of the house and one's like right flush with the garage.
And this one's not flush with the garage, it's back, set back into the
Okay.
house.
And what's this here? Is this the mountain?
Yep.
All this stuff's mountains. Oh yeah. Yeah, that's kind of grim. This one's better. So the first one's side of the garage, flush with the front, so less house shading. Now, why are you saying nothing in December at all? Where, somebody said there's nothing at all in December. Oh, I see, yeah, December's this top little band.
Yeah.
And you're not catching, you're not, I mean, it gets pretty,
Well, I traced over with the Sharpie, so the wax is actually closer to the top.
yeah,
You'd have to.
You might be getting some for like
You-
an hour.
You're like,
maybe.
Yeah.
plus or minus 30 minutes.
But
Yeah.
indirect and not even enough to generate heat.
December and November's pretty wimpy too.
Yeah, all the key months where she really needs it,
Yeah,
it's not there.
yeah.
In
Okay,
June, it would create heat, no problem.
okay. Now,
Actually, it's still, I mean, it's cold in that canyon still in June.
you can use it as a cold,
Until the
cool.
sun gets in.
Yeah, then it's warm.
Yeah,
At which point
yeah.
it's already there.
So, technically, you could heat your garage in June.
Or, I mean, if you were designing it to run in two modes like you're thinking about, Ryan, you could do some cooling in the summer too.
Yeah, but the position for my coworker's house is much better.
Okay.
Because
And then, Joe, how about where you're planning on putting yours? Do you have yours, site select, I forgot, sorry, it's mine, yeah, never mind, sorry. I'm awake, I promise. I guess the one thing I want to consider on my office is that we'd be able to cheat it towards the east a little bit, yeah, okay. All right, plywood, polycarb, good. And I was talking a little bit, one thing we need to add to this guy is now, did you paste this in as a picture?
Can't remember, I
It
think
look-
I imported it
From Excel?
From Excel.
Okay, that's fine. Let's just do this. So add roof sheeting, insulation. And this is something I was just looking at Ryan with. Let me just show you what I'm talking about. it's gonna be, this stuff right here,
Oh, yeah.
that's really important, not this exact thing, but, do you remember what your materials were, Tim, on yours? Was it some kind of foam or,
I've used foam and wood. I use wood
Oh, yeah.
exclusively now.
yeah,
This foam will melt.
yeah.
Because it gets so hot.
It gets so dang hot, yeah, so we need to find a wood, let me put that
And
in
the
there.
wood's actually cheaper than
And
You can
do you,
just buy it
do you
like
just
that?
use,
Yeah.
You use pressure treated wood,
the, nope.
there's normal wood, so you would stain the outside. Prime it, paint it.
So add roof sheeting, I'm just gonna call it insulation/wood, because this is gonna keep the top and bottom from leaking out.
Right.
And just that one little piece is probably gonna improve the overall performance by a lot, I don't know, 20, 30, maybe 50%, because otherwise just gonna spray right out of there. So that's key, that you get the right closure strips, they're calling them here.
And what you do is, you have that attached right to the frame, and lay a bead of caulk.
Right.
Silicone caulk on top of that, so you get it really tight seal.
Now, you're saying brad nails here, but I think don't you want the nails with the nice big plastic flange washer around them, or what do you recommend on that?
What are you nailing down? What's it for nailing?
Oh, metal roof screws?
Yeah.
Those
Got
self-tap.
the gasket on them.
You have a
Yeah,
rubber gasket, those are,
yeah,
for the plastic, that's the way.
Yeah,
to
the
go.
Yeah.
brad nails are just for the frame.
So
Okay.
self-tapping with the rubber on them?
Yeah. And on that, Joe, I'd use my nail gun just to tack it together, but then I used wood screws or
Yeah.
deck screws to really solidify things.
So 3
those
inch.
things will just break off, that head for that screw will just break right off if you're not careful.
For what?
For those self-tapping metal roof screws.
Well, yeah, he's screwing them into wood, not
Yeah.
steel.
no, yeah, you just want to put your clutch on your drill. Now, are you pre-drilling your polycarbonate, Tim, or not?
Yes.
Yeah. So be sure you pre-drill that, otherwise you run the risk of cracking it. Just pre-drill where you want your holes. Heat-resistant caulking, fiberglass insulation roll, that looks good. Metal roof screws, brad nails, 4-inch flex duct. What about insulation around the duct?
Yeah, I was thinking about that. They make insulated flex duct, but it's
Mhm.
usually 8 inches or more
Mm-hmm.
in diameter. I don't think they make like 4.
Tim had some nice fiberglass insulation that had a,
They make insulation just for that duct. It has a foil exterior.
Right.
yeah. So,
And then it's designed, you just wrap it around and run a duct tape seam on it. Works great.
okay, I'll just put that on there, foil backed. Also, ROLL, just a little typo there on that. I do that all the time.
Yeah, it was late.
No worries.
Look at-
Nails, yeah, whatever, okay. We get the point.
Did you post this on the project and then borrow your material list?
And then, let me see here, did you guys, I guess another thing I'd like to see, and let me just do this one while I've got your attention here.
Got the plywood.
I think you can get away with half-inch, yeah. Half-inch plywood's
You know,
fine.
over that, is that, not plywood, the fiberboard or whatever, is
So
it?
OSB or?
Yeah, whatever.
No, I would use plywood.
Yeah, that's just gonna swell up on you
Yeah,
after a
OSB
while.
is full of glue and when it gets wet. it starts-
Or really hot.
Or really hot, yeah.
It could fall apart on you.
I
Good.
used, the backing line, it's not regular plywood, it's composite siding that you can get in sheets, it's like for sheds and stuff, and it's actually cheaper than plywood. But the stuff's indestructible, it's really thin, you don't need I think it's only 3/8 inch, you don't need much.
Because here's what I'm thinking about for the, to get some tilt on there. And, feel free to veto it if you want, but here's what here's what I'm thinking about for the, if we've got a triangular frame like that sitting on the side of the house, right? Gosh, this is one of those Necker cube problems, isn't it?
Yeah,
Where the,
that's
where the heck did it go? I'll draw the, this is the front of it.
That's the frame.
Yeah, so this is the front. I guess what I'd like to see is, rather than a rectangular prism, to see a triangular prism as the frame, and then your unit, the system sits out here, and the only trick is going to be just getting some kind of pivot going on the top and the bottom. Let me
Piece of iron pipe.
Yeah, that doesn't have to be too fancy. Let me just get that lined up a little bit better. The unit's sitting here on the front like that. From the top, get this line a little bit thicker. From the top, if this is the wall. Now, here's the other deal, is this leg right there has to be longer than this leg right here. So it's not exactly a triangular prism, is it? It's a,
So it's still at an angle?
yeah,
And tilts this way?
yeah, yeah. So so you still have an elevation angle, and do you remember what angle you used, Tim?
For inclination?
Yeah,
It's, on the fixed one is 62 degrees.
yeah. It's nowhere near 45. It's fairly straight up. So, and that's really because you're sort of cheating it towards a winter mode, right? If it's if you're going year-round, you'd have it closer to 45, but you're sort of cheating it so it's pointing more directly at the sun when it's colder.
Right.
Okay. So from the top, you'll have, here's your top pivot, and then your bottom pivot is going to be more out here, so it'll look like so. And then steel pipe going so that's a nice solid structure. So here's your top view, and then the
So it's just, so you can swivel it around that and then secure it in?
yeah.
So with some kind of, so it's just support system from the two sides?
Yeah, we'll get to that here in a second. But if we're looking at the, so here's your front view. We'll just do this as a top view, and then we'll do this as a side view. We basically just look, and so right up here you've got your kind of header materials, your beefy exhaust manifold, and here's your intake manifold, where you've got that nice 2x4 frame inside.
Right.
It's just going to be a matter, and I think you could probably get, just in terms of keeping it compact, I would suggest doing your little pivot bracket here.
Yeah, you'd have to screw it into that 2x material.
Yeah. So if you got your 2x up here, another one sitting here, maybe something that's got enough kind of flange to it. So let's say the thing's 4 feet wide. Maybe this flange is a foot and a half, and you get a few places to screw into. and then your actual bearing is right there. Right. And then same thing, top and bottom.
Right.
And then just the same deal down here, some little bearing. Where'd you guys get your materials for the PV you built
Like
this
the
up?
Unistrip?
Yeah.
Just at Home Depot, I think, or
Yeah.
at this Home Depot?
Yeah, it was just kind of big, beefy.
Yeah.
Cheap, strong enough.
Mhm.
So same thing here, you're sort of bearing.
If we could scratch some stuff off the chain link fence at the.
Oh, I like that.
Oh, goodness, there's a plan.
Yeah, and then from the top, you'll just have your sort of flange here. Your bearing will look something like that from the top view, and then from the side, it'll just stick out a little bit like this, little bearing.
I think I could use a few pieces from that electrolyzer for some.
Yeah.
That's a whole nother can of worms. All right, now the next thing we got to think about is how do you pin it to a certain to a certain spot. Let's think about that a little bit. So if we've got the this is not going to be really a top view, but this is just going to be looking straight down that tube. And so we'll just do a little brainstorming here. One thing would be to have some kind of steel plate with some holes in it and some kind of pin dent. So that would be,
Well, if you're gonna,
some kind of
Yes.
little pin system coming up through a plate.
just, like, I would, guess I'm not sure about
Think you're-
about this. In the ability to move it,
Yeah,
there is a need for an ability to be able to change the inclination of it because of the different
times a year.
azimuth of the sun.
Yeah,
But the actual location of the sun in a north-south pattern doesn't ever vary. So unless you have a tracking system, is there any point in having it pivot on the vertical axis?
yeah. I think so.
Because you were wanting to get the mornings.
'Cause I'd really like to, in the morning, like, you leave the office at night, and it's not like that tracking system that was at the, on the solar, the
Right.
panel, the PV panels. But you leave the office at night, and you point it as far east as you can get it.
Right.
Sun comes up, starts making heat for you. And then, so you're really maximizing the solar gain in the morning, when you're not even there yet, maybe.
Right.
And then, but then it's later in the day, like right now, and I want to keep cooking, so I move it a little bit manually. I mean, that's one reason. It's a little bit of a pain in the butt, or if you're just like, screw it, I don't want to touch the thing, just pick a spot that works and just leave it there. But at least you've got the ability to put it where you want it. That's another reason. And then a third reason is for educational, for data collection. If somebody wants to see, does the angle really matter? Well, we can go out there right now and test it. We can point it in one direction, take some temperature data, point it in another, and then we'll know. We'll know if it matters or not. So I guess those are my three reasons. Is that enough?
Well, here's my thing is,
I see your, you're like, let's just keep it simple.
Right.
But on the other hand, like, I want to make it slightly more complex for those reasons. One is that, it gives the user some flexibility. Two is you can, just at least feel like you have flexibility.
Right.
Even if even if it doesn't matter. And then third, you can prove to yourself whether or not it really does matter or not. And for me, that's where the value is, because other research teams, other schools, whatever, might look to us and say, well, guys, did you check, did you see if the angle matters? Well, yeah, we did. Look, it doesn't. So just put it, build how you want. So is that, I guess that's the reason.
Here's my thing is, I'm gonna put it there, and he's not gonna touch it really.
Right.
So, are you saying it has to have an inclination of 62 degrees and then face it southeast?
Yeah.
To do the garage heat?
Yeah.
Okay.
Yeah. Why don't you not mess around with the whole angle thing, but I guess this is what the burden I'm putting on poor Joe here is to come up with something. Do you have a partner, by the way, on your?
Oh, yeah.
Is it
Jesse, I was supposed to.
Okay. Yeah. Have him help out, he's a good fab guy, yeah.
Is to literally make the bottom's gonna be the easiest, but, and you're gonna have to build them both like this, but if you wanna play with the inclination, you would just put one tube inside the other and drill pins in there, and that's your entire, you could literally make it however you want.
Say again now?
Okay, so, scroll up. Those don't really matter. It's the two, so these triangles.
Yeah.
Okay.
Top triangle's smaller, bottom triangle's bigger.
No, I'm talking about the piping.
Oh.
So you would put two in there, and then you drill a hole, and
Mhm.
you could change the inclination that way without messing with all that.
Well, so you let these two bottom guys telescope?
Yes, there'd be one pipe inside the other,
Mhm.
you just drill a hole, and then you got play with your inclination.
Yeah,
You'd still,
You'd have-
they would both have to be.
you'd have to pivot here if they were telescoping, because the
Yes,
angle would
yeah.
change, but,
That's what I'm saying. Well, it's not that hard, but
Yeah.
that's the easiest way to make if you want to do testing,
Mhm.
that's the easiest way to build it.
mhm.
That would do the inclination, but it wouldn't do the tilting. You would need supports to keep it in one.
To do
on
the
one
tilt, well, once you change the
It could be
inclination,
pretty easy to
you
do.
would color the outside too. So coloring that, and then you can just index, you can literally weld on one part onto your bottom or top, and that would change the inclination. So you would weld one point to one point, that indexes off wherever that is to the panel. And then you could just literally cut to length of
Yeah.
the rod. And that,
No, I like it. I mean, that would be a nice way to adjust it, just have something in here, but I think we got plenty of complexity going.
well, it's real simple, it's just hard to explain.
Yeah. No, I'm with you.
Yeah.
I'm with you.
But I really just need what's in Tim's head. on
Sure,
paper,
okay.
So I can build one of these panels.
Okay.
And do it right the first time,
Yeah.
so I don't end up having to build it twice.
Yeah.
Because I want it to look professionally really nice.
Yeah. Well, and the reason I was talking about Nikki's system is I'd like to get that thing up somewhere so we can all see it. It's just instead of sitting my poor
When I put this
backyard.
one on, I'll take plenty of pictures.
Okay. But what I'd like to do is somehow get the one in my house somewhere where you can more easily access it.
Yeah, because this is down in Stevensville.
Yeah.
I don't think.
I guess we could bring it over and put it in the bullpen. Maybe that's the next step, just get the thing over in the bullpen. We can see
Well,
this.
if you want to, there's plenty of sun here, you can literally hook it up, like, you don't have to modify the trailer at all, you can literally just take out the top fan and make a cover that fits inside that porthole, and it literally will do exactly what you want it to do.
Yeah.
Set it on the ground, and you can have temperature sensors in there and bam.
Totally, man. Okay, so I think we got the materials locked in, detailed out. Okay, plan for data collection.
So it's supposed to be 2x4s or 1x4s in there? You have one on there, your 1x4s.
Oh,
I've got a bunch of lumber at my house that I'm gonna be using too.
yeah,
Well, I'm gonna go buy
I got all
one,
the
but-
2x material I need.
okay. Is there much need for 1x4s, Tim? I thought it was mostly 2x4s.
No,
Can-
it's the outer framework is all 1x4.
It is.
2x4s are only the
Interior, yeah.
inner headers, but even those could be.
They probably could be 1x. Yeah, that's not that,
You probably want 2x4s to.
bolt into, yeah, I think
Yeah,
so.
I use them as
beef it up for, yeah, the structure, okay. All right. Temperature readings, now, let's see, temperature readings from the panel, inlet and outlet ports. And let's just say, yeah, let me put it over here. At, I don't know, have you guys used these little Omegas before? I've got a bunch of,
Thermometers.
Yeah.
That we were gonna use for building energy efficiency.
Yep.
No, I haven't used.
okay, I'll get you guys those. Let's just say at 15-minute intervals. You can,
USB ones?
yeah, you program them, and you just sort of set them up, they'll read, so at 15-minute intervals, over a, let's just say 3-day period, something like that, 3 to 5 day period, interior and exterior. And I'm thinking that I would love to see interior, both intake and exhaust manifolds. So you'll have 3 separate readings. You'll have just the outside air temp, intake manifold, which is essentially the temperature in the room, and then your exhaust manifold. I think that's probably, because that's going to give you your delta T.
Right.
That's going to give you your power system.
How would you get your delta T from that? The low temperature would be the outside temperature?
No,
The intake temp.
yeah, the low is just going to be the incoming from the room, and then the outgoing, because the
The outside temperature doesn't matter all that much.
no, what, and this is not a 242 thing, but what it'll give you is it's more of a 235 thing, which is like heating degree days. Because, from there you'll say, like, I'm this many degrees below where I want to be, I'm putting this much power in. That's what you'll get from these 2 temperature readings, and that'll basically tell you, is the system size sufficient to do that? Okay. Oh, the thermal imaging camera, perfect, okay. Let's just say at, let's just say 3 readings per day. Like, morning, noon, evening. You could even, I guess you could even do something late at night when you really don't want heat to be leaking out, and if the system is pulling energy from the building, that's a bad thing. So morning with a night image as well. I'll just throw that in there. Let's throw that. Oops. Okay. Theory. H is the heater output. Let's just use Q for that. Or, did you have a reason for using H?
Makes more sense.
Yeah, thanks. Because,
All that is.
yeah,
It's engineering.
I know, yeah, you got to make it really confusing. H actually stands for enthalpy, and enthalpy is it's heat per unit mass, and we should use Q because Q is thermal energy.
I just took that off of, what is that toolbox, the.
Engineer's toolbox? Oh, really? You found it there?
Well, yeah, like.
Well,
Shoot
doesn't the density
shoot
of
me
the-
that link, because I'd be curious. They might actually be talking about enthalpy, and I want to make sure we get those 2 things separate.
Isn't that per unit mass though, with the density involved?
Yeah, but it's a little more subtle than that, because if we got CFM, enthalpy is not we're looking for power here, and enthalpy is just, it's how much energy, how much thermal energy is in a system. It's not how much is flowing through it, it's how much is inside it. So I want to be pretty clear on that we don't, there's nothing wrong with your equation, it's fine, it just kind of gets down in the engineering weeds a little bit, so.
I'm not an engineer. So
That's okay, that's why I am, that's why I pay to confuse myself all day long on this stuff.
What's the control system for this one then?
I think it's just Leighton plugs it in or not, I don't know. Did you have a plan in mind for controlling it, or just,
not yet.
yeah?
I think, I mean, it'd be nice to have it automated.
Use a thermostat or something.
Right.
Like an inside the thing thermostat.
Yeah, so here's my thing is, like, the one that I'm gonna put in, I want it to literally be on like a switch, so you have like two different settings, so like summer and winter,
Mm-hmm.
and then that would tell your program logic, however you pronounce it, let's call it
Arduino,
Arduino.
you got it.
So there needs to be a inside, so anything below 70, then you need to have a photoresistor tell it that there's light out, and then you need the upper panel temperature to say it's above 70 to turn on.
So here's what I'm doing, is I did Control I for italics. So Control I toggles italics, and then Control equal does subscript. Control equal. So that's, and the other thing that's pretty handy is this shift left arrow. That way I'm not hitting the mouse at all. I would do that. And typically the subscripts themselves are not italicized.
Oh.
So another one, I would run this thing. Down here, if you do Control E, that just centers it. Typically equations are centered. This guy, this is kind of picky, but no caps on that, and also no indent on this either, because the word where is still part of this sentence. So throw a little bit of, it's just using the heating power equation. Introduce it like that, using the heating power equation, H equals et cetera, where H, so it kind of reads like a sentence. Like, imagine, and this is actually pretty serious, imagine you were blind and someone had to read this to you. It would have to read out like a sentence that you could then transcribe even if you couldn't see. Here's another one for you too. Under paragraph, do this keep with next, because it'll keep, and you do this again, I'm going to do Control Y. Control Y means redo, so I just kept both of those paragraphs with the next sentence, so it keeps all that in one section. So keep with next is pretty good. Control Shift 8 is also quite good. Control Shift 8 turns the meta characters on and off. Okay. Temp theory, that looks good. Now, what I'd like to see, if you could, now take the theory and predict the power output of your system. And it should be pretty straightforward if you know the delta T's. And if you want to get really fancy, you could try to do it. If you want to get really fancy, you'd go back to your Solar Pathfinder and figure out, as a function of time, how much juice this thing's going to put out. Don't kill yourself over it, but that's kind of where you would go from there. If you were sitting at your desk down at Sunelco, and your customer's like, how much is this going to make February 29th? Well, here we go. It's in my model already. But just think it, and again, if I drop something like, there's no way I can do it, that can be part of your future work too. Almost every project is going to be, here's future work. Or, what's the control system? Well, it's going to be future work, or whatever. It's okay. Don't be afraid to put stuff in that you don't think you can do, but it's just your own little to-do list. Okay. All right, that's enough time on that. I want to look at this other project, then we'll go out and fix the turbine. Did I have to kill that whole thing? No. Here. Why did I get out of the website in the first place?
Good question.
Thanks.
Not a delay.
Okay, let's just go back down to the other one here. Let's see what's going on. Project draft upload. So Joy, I hope that's enough to kind of get you off going.
Yeah.
Did Cooney just submit the same thing, or is he on something separate?
Might be on his wind turbine that is.
Oh, yeah.
Oh, that's right, right.
At his parents' house or something.
I could probably help out with both Joe and Justin, since I don't have my own.
Okay, that'd be great. Please, by all means.
Our proposal for me and Adams is in your email.
Okay.
I have it too, I can put it in there too.
This is what I am not digging. Open file. Microsoft Word, do something. Whew! Okay. Mountaintop Garrison, Montana. Okay. Charges single 12-volt deep cycle battery to use completely off-grid. 15 feet, all right, nothing to be ashamed of. Wind supplies approximately 5.7% of the electricity in the United States. That's good. Off-grid users, just fix a couple typos here. Cooney. If you see a red, it means get rid of it. A green means put it in. Red stop, can go. Well, off-grid users account for an unknown amount of wind produced. Okay, and I'd kind of like to see a reference on these guys when you're especially in your backgrounds. So throw a reference in. Boom. It might be the same reference too. Kind of hard to reference something you don't know, but somebody might have said we don't know, and reference them.
We don't have to show them the property tax since they have renewable energy.
You can provide sufficient electricity for people to live comfortably off-grid if the area in which they live has reliable wind. Good. Wind turbine used for a home built with no official design used. I'd like to know, well, no, he's just building it custom. So fundamentally, I want to know if it's vertical axis wind turbine or horizontal axis wind turbine.
Horizontal.
Huh?
It's horizontal.
Oh, thanks. The housing for the generator is made of PVC. For the rotor and blades, it purchased fabricated and the solar, the mounting system, base attached to the towers, made of steel pipe and washers. Sheet metal, mounted steel pipe, electric metal tubing. I'm going to tell him, I don't want the dang thing to blow over. Please send me the specs before you get too far on this. I also don't like that word, it doesn't leave the comments. I guess you gotta click on it. Okay, well, I guess that works.
And it's already up, by the way.
Oh. Also, this should be a big V for volts. I'm gonna throw that in green, throw that in red, deep cycle marine battery. This is little m right here. Battery refers from battery systems, simple solar charger. Oh, I need the brand here. Brand and model. Guys, this is relevant for all proposals. You gotta put this stuff in there. So it's using Connect. Bill Small, vented. Throw a picture in here. Oops. So mount the charge controller. This guy too. This has to be big W. Peak demand.
What about when it's in a word? That's fine, right?
What's
You
that?
actually spell out watt, it's fine.
Yeah, the only unit that is capitalized when spelled out is Celsius. Don't ask me why. But in almost every abbreviation is caps. Overview systems. Okay, so this is good. Tested with an ammeter and voltmeter, but I need to see tested relative to what? I'd like to know what the system's predicted output was. So I'd like him to compare that to theory. Which I don't think I saw a section on theory. Oh, yeah. Here's an example equation written into a sentence. We begin. Okay. That's good, though. I think that's correct.
Did a good job with
That's a really good start. Well stated. Now, please supply numbers. Boom. Okay, that's great. I mean, this is really all I need to see for the proposal. Field experience. Here's the non-breaking space. Good. That looks good. That's a really solid proposal. Okay, one more. Did you say? Did someone send me something in the inbox?
I said I'll put it in.
Okay, all right. Well, it's good. We just reviewed one solar thermal. We reviewed one wind. I showed you a few little tricks in Microsoft Word, so hopefully helps. Be nice to get Jesse an anemometer. Do we have kind of a portable anemometer in the wind turbine trailer, Tim, or is that something we should buy?
Just something we need to buy.
Yeah, okay. I'll email myself. It's my to-do list. Guys, how do you feel about tomorrow, just instead of just doing a lab day? I figured Wednesday lecture, Thursday lab is probably good.
I don't, we really need to hammer it down since we have like 2 weeks.
Well, I'm saying tomorrow, I'm trying to hammer down tomorrow whether or not we're going to be sitting in a room.
What do you mean by lab day?
Well, go out and buy your stuff and start getting ready to build. I mean, I think your time is better spent now getting your supplies, not messing around in the classroom. I think we did plenty of report review just now. I showed Ryan Tim's report, full proposal or report from a couple of years ago, so I think we're back on track, racing to the finish line with a couple of weeks
My
left.
thing is, I just need to know the parts list. I just want to, I gotta use the work truck, so I can't use it till the weekend to go buy all the stuff.
Okay.
My thing is, I just need to know how it all goes together.
Well, if you guys want to just tag team and get a 2-for-1 going, that's fine with me too, if you're
Just
going,
build one,
well,
going on.
apparently Ryan has money already to buy the parts for his, and it sounds like you wouldn't mind just being reimbursed. So if you guys want to go to the store together and get 2 of everything instead of going twice, just suggesting, might be an option to make it simpler.
Well, back to the point, I'm going to build it at our shop. so
Okay.
I can't build it there.
Okay.
Or drop the parts off till this weekend. so
Okay.
it's,
Well, another option, if you got room in your truck, is to go, just make one trip, bring it all back here, do some triage. Or what were you planning on building?
Just my shop.
Home shop, yeah.
Garage.
That's kind of where I end up building my stuff too. No, you guys can figure it out.
Move my raft.
I don't need to micromanage it. What's that?
I have to move my raft.
Oh. Yeah.
Actually,
It's
my
kind
question,
of downward bracket.
my
I
question
just don't
is,
like it being
Who-
outside.
who-
No, you-
My raft goes in the garage now.
how do you control your solar thermal system?
Which one? I've got 2 of them in my house.
Do you have an air-to-air one?
Yeah, both of them are.
Okay. What kind of controller? do you
One is
use?
just manual to turn on and off. The other one has a thermostat in the exhaust side, and when it reaches 120 degrees, it turns on the fan.
What kind of thermostat is it? A little Mercury guy or?
Some cheap $5 off eBay,
Yeah.
just an on-off switch that is triggered, and you can get increments like 2 degrees, I think, something like that. So just set up 120-degree thermostat, and
It's got a battery in it?
doesn't have anything, it's just a little brass.
But what,
But it's like, all it is, it has 2 prongs on it that you wire it into the circuit,
yeah.
and it just acts like a toggle switch.
So it doesn't have a power source, the thermostat?
No, it's,
It's probably a bimetallic.
Right.
Yeah, okay, yeah, okay.
So that, you would just put that in the top of the panel on that kind of.
yeah,
Yeah.
with 2 wires going to it, it completes the circuit that
Yeah.
comes on your fan.
Yeah.
So you just have your hot wire that was going to your fan, have it run through that. So when it turns on, it supplies power to the fan, and it runs.
And you got that off where?
eBay. And when it drops below 120 degrees, evening time, it turns it right back off.
Turns off. Slick.
I think I got,
Yeah, it sounds like the way to go.
Mhm.
yeah, maybe 7 or 8 bucks in that whole system.
Nice.
So my question is, will you drop the schematics on how to do it with this stuff?
Seriously? This supposed to be good for fucking wire?
No,
Wire.
no, not that.
I think what
I'm
Ryan-
not concerned about doing that. What?
Well, I guess all Ryan's asking for, Tim, is something, so we went over, we went over this guy, Project Final.
And you could get like all these different technical things, but I don't care if the room temperature is above 70 degrees in my house, because the one where the room that dumps into is suction side for my furnace to heat the house. So I don't care if that room is 100 degrees, because that just means it's 100-degree temperature going, and it's in my basement, it'll never get to 100 degrees. That just means suction for the furnace is 100 degrees, and the heat flows up through my house, so.
Which makes your furnace more efficient.
Yeah, when I go into that room, even on a hot sunny day and that thing's just cranking, blowing, 180-degree air into the room, it might be 75. Which kind of sucks, because that's my hobby room where I do my RC airplanes, and my wife wants to hang out in there, because it's warm. It's kind of bogus,
It's
but.
the man cave, man.
Exactly.
No, see, I only want to build it once. The panel. I don't want to does it go like this? Does it go like this? One time.
It's a pretty simple box. really.
Yeah, well, no, I understand the box.
So it depends. You may not want to build it your first thought is, oh, I don't want to build it more than one, but then when you watch your heating bill drop with each consecutive one.
Well, I'm not,
Too bad.
I'm just putting this on a garage, but my coworker says, he said, sure.
Well, so somewhere between what you're seeing here in Tim's report and, gosh, I don't know what you're seeing here, are your drawings, really. And if you want to, I think it'd probably be easier, rather than us just like, here's how you do it, if you come up with some hand sketches, or what do you?
Sure.
I mean.
Fix the winter.
Everybody I interact with gets mad because they're like, how'd you build that? You know, even my boats don't have plans.
Yeah.
It's all in my head.
Yeah,
I build things the same way.
Yeah.
It's just really hard to transfer mine.
I know.
But that's the other thing, I don't want somebody else's plans because I'm smarter than them.
Mm-hmm, that's right.
So I do it in my own head.
My method's even crazier because I don't have any plans, and it's not in my head, it's just whatever's around.
This, that.
I'll leave that pile of shit in the corner, I'm trying to
You know what,
get
that
some.
works for cooking. I do that for cooking.
cooking, yeah.
You know, you're making a pot of soup, that's awesome.
Unrepeatable.
You just name it. Damn.
Oh,
It's a
man.
way for no one to ever steal your invention.
Yeah, totally.
So I don't even know how I made this.